You're now working at OpenAI on the LLM Evaluation team. First things is, well, how did you join OpenAI?
I actually wasn't looking for a new opportunity. They reached out to me. It was kind of one of those opportunities that was very difficult to refuse.
I have two models. How do I really know that one is better than the other?
There are two ways to kind of tackle product thinking. And one is problem oriented, which means okay, there exists this problem or this expensive process that we want to optimize and fix. On the other hand, there's more of the novel, innovative, research-led approach. Being able to measure and improve the robustness of your classifier is a very important aspect of your application.
So OpenAI released Sora, we've got ChatGPT, so multimodality is probably the future there. Agents are also becoming more popular, but where do you see the future of GenAI and LLMs?
The word AGI.
This episode is brought to you by Training Data. If you're new in data science and want to get into the field, or if you're already in the field but want to progress, well, Training Data is the platform for you. They offer courses on feature engineering and selection, model tuning, interpretability, and much more. You will get both the math and the intuition behind each method, but also Python code ready to power your own projects. So if you're interested, visit the link in the description and don't forget to use the code AI Stories to get a 10% discount. All right, so hello everyone and welcome to the AI Stories podcast. I'm Leiser, I'm a senior data scientist and I will be your host. So today we've got a very exciting guest, Reah Miyara, who is working in the LLM Evaluation team at OpenAI. Prior to this, Reah had a bunch of experiences. He worked at Google and also worked at IBM, where he transitioned from being a software engineer to working in AI and product. Reah also did some studies and he did a bachelor at the University of California, Berkeley. So today we'll talk about Reah's story, about AI, OpenAI, GenAI, LLMs, and much more. So if you enjoy our conversation, please subscribe to the AI Stories YouTube channel, comment, share, and leave a 5-star review. All right, so let's start now. Reah, I'm super excited for this episode. Really looking forward to chatting with you and learning about your experience. The first thing I wanted to know is how did everything start? How did you get into the world of AI and machine learning? How did you get into the field?
Yeah, well, first off, thanks for having me. I'm very excited to be here. Um, it's a great question. I actually fell into AI by starting a club at UC Berkeley that was focused on building drones. So I guess I was probably a sophomore at Cal at Berkeley, and I had just had my first internship at NASA Jet Propulsion Laboratory. And while I was there, I was working as part of the Mars Science Lab on a piece of software that communicates data or telemetry between the rover and our command center. And I got really interested in things that fly naturally. And so while I was at Berkeley throughout the year, I decided that I wanted to build quadcopters. And because I was kind of this college kid without a lot of money, I figured the easiest way to do that would actually be by starting a club on campus, because you get minimal funding if you get approved, and then you can actually seek out sponsorships. And so, yeah, in founding the Cal UAV team, the Unmanned Aerial Vehicle team, I basically got a bunch of friends to uh, get into a room together and start building drones that are controlled by uh, a remote control. And I think like the moment we started crashing at the time, these pretty expensive, like little mini flying computers, we realized we actually want more sophisticated things to help avoid objects and help us not crash and help us like control it better. And so um, at the time, we were just kind of like, when I say we, it was actually a pretty small club. Like, I think I garnered maybe four other people who like showed up semi regularly. Um, yeah, so we were started messing around with this Arducopter, like Arduino based flight controller software, and started programming very basic, like let's call it like quasi AI decision making on whether something is an object or whether it should be avoided. And, yeah, I'd say like early on in my career, in my studies at Berkeley, was when I kind of discovered um, that you can have algorithms that make computers think and act and try to behave like human beings. And eventually that led to taking like a couple classes with Peter Abil, who's freaking awesome. And from there, it escalated.
And so, what do you like so much about the field? I mean, why did you stay in AI since then?
Yeah, it's a great question. What I find fascinating about artificial intelligence is that it is, in a way, like very closely modeling humans and our own neural networks and how we think and behave and act. And I think that, given that we have some, finite memory and like finite decision making capabilities and like are very much influenced by everything from, you know, the weather to our emotions, I found it extremely like rewarding to be able to uh, build machines or software that are able to help make better, more sophisticated, and more nuanced decisions uh, that can actually like propel and advance different technologies and solve problems such as, you know, diagnosing different medical diseases or, synthesizing drugs. And I think that it just provides this unparalleled level of advancement for good in the hands of good people.
Yeah, I kind of agree with you. I'm a big fan of solving problems, and so very quickly you realize that machines are, first of all, better than humans in some very specific problems. For example, computation or calculations. If you need lots of calculations, obviously machines is going to be, and algorithms are going to be much better. So that's how I actually got interested in algorithms and AI. But today we might even be at a point where you're not good at a specific task only, but you're good at some general task like LLM, for example, which can really answer any kind of questions you want. And who knows, maybe in the future we'll have someone like a human, a robot, who can answer you, see things, do stuff for you, and be better than a human at everything. But yeah, for me, it's the kind of the thing that AI can really solve a lot of problems. That's the thing that really interests me.
Yeah, and I agree with that. I think AIs are much better than humans for many specific tasks. And I actually, I'm more of an advocate for uh, AI facilitating or collaborating with humans to make better decisions in this kind of joint collaborative fashion. So I actually really enjoy with when systems present information to me um, in a way that is insightful, that
Mm-hmm.
is, pattern matching or uh, something novel that I couldn't have noticed any other way. And so I actually am very much an advocate for like not thinking about AI as completely,
Mm-hmm.
replacing humans, but actually, collaborating with and advancing mankind.
Okay, yeah, no, that's also that joins also what I think. Like humans have some great points that algorithms don't have. For example, high level decisions or even telling the algorithm what they need to do. And so I definitely agree that this collaboration between humans and AI is maybe the best way to solve very difficult problems. You don't need humans only or AI only, you need a combination of both. But I want to dive into your experience. Then you worked, well, you studied computer science and engineering, but you start to get into AI by building some kind of drones. And after that, you have a bunch of experiences. You worked at IBM and at Google, as I mentioned. I believe that at IBM, you start to transition from being a software engineer to working on the product side of things. So, do you want to talk a bit about this transition from software engineer and very technical topic to being more of a product person?
Yeah, absolutely. My first kind of post undergraduate experience was at IBM Watson, so within their AI division. Um, but actually, my passion or interest in product, which is kind of like the way I view product, is really a hybrid of uh, technical decision making and critical like problem solving for user pains and customer needs. It actually started, I would say, in college as I mentioned already one of my,
Mm-hmm.
side projects, which was building the Cal UAV team and building drones, but all throughout college, I kind of was building different what I called crap apps, which were these very small, hacky, not scalable, zero best practice
Mm-hmm.
implementations of some piece of software that was like probably selfishly motivated to help me like organize my notes or to help me like buy concert tickets or whatever it was. And so I felt as though I became fairly product oriented by trying to solve my own daily problems. And I did study electrical engineering and computer science and like was a software engineer at IBM Watson for about a year and a half on a team that was um, actually unique because IBM is traditionally like business to business software, and I joined a team that uh, was focused on a consumer facing product, which is pretty new. It was right at the time where Watson was uh, being packaged as kind of like a set of APIs, but it was difficult for IBM to communicate the value of like this novel AI technology at the time. Um, and so what we came up with was building a chef assistant. So like it was called Chef Watson.
Mm-hmm.
Um, and I was a software engineer on the project. And the goal was to basically use AI to like scan through a database of recipes and ingredients and like identify ingredients that work well together down to their like chemical composition. So like maybe you don't think naturally that jalapenos and chocolate actually have like a really similar chemical composition and might even work well together in this like novel recipe. But it turns out that like AI can surface those patterns. And um, yeah, it was really interesting because while I was working on kind of more of the natural language APIs and components of this Chef AI system, um, I found myself kind of like questioning certain decisions that were being made on how to like expose the software and like different features that I imagined coming from like an Israeli home where my mom cooked all the time and like recipes were passed down from generation to generation. It was like something that I started seeing surface again, this kind of like product thinking as to like new features and new functionality and like what are the real pains that our users want, and like politely immersing myself in like some of the customer discovery. And it I really enjoy engineering, in terms of like being able to uh, use a technical skill set to truly wake up and bring an idea to reality. Um, I think that the way I maybe felt in my first position was kind of like I was pigeonholed into a single part of a much larger
Hmm.
application, and so I kind of started asking the right question, and I am very grateful that I had the support and the environment where I was encouraged to do so. And so actually, while I was at IBM Watson, eventually the opportunity presented itself where I became the product manager, or the associate PM for this team. Um, yeah.
Okay, so you were keen to. It wasn't enough to work on a particular features. You wanted to give your ideas on the product and maybe also have a broader impact. And so you decided. I mean, you decided and you joined the. Well, you became the product of this project.
Yeah, I think like the that summarizes it succinctly, which is like I wanted to push features that weren't on our
Hmm.
roadmap, and I believed that sometimes like the things our customers really wanted were slightly different than what they like needed immediately. And so I would do my best
Hmm.
to present that data in an objective fashion and say, hey, look, 35 people of the 50 that we surveyed like are would pay for this feature. Um, and so surfacing those insights was how I helped influence the roadmap. And I realized very quickly that I was kind of like doing the product work that I remembered or I was familiar with by, building
Hmm.
again what I called crap apps in college.
Okay, and so talking about product, a couple of years later, you join Google and you're a product lead in a couple of technical projects. So, do you want to chat a bit about your experience at Google and maybe talk about one particular AI project that you worked on?
Sure. So yeah, I joined Google AI, so their research and machine intelligence division in New York, and I was there for about 3 years. Given my background and my interests, I very much find myself like most passionate about working on like very technical products for the reason being that I find them extremely challenging and complex and nuanced. Uh, I was the product lead for the uh, graph algorithms portfolio at Google. So um, tools and algorithms that were developed by researchers used to build graphs and cluster on graphs and propagate labels throughout graphs. And graphs are just a single very prominent data structure that exists. across various applications. And so this suite of tools and products were used across projects like YouTube's Watch Next algorithm. So
Hmm.
the video recommendations that pop up when you are watching a YouTube video, and like people often, find themselves falling into this like YouTube rabbit hole.
Hmm.
It was used across like Waymo's navigation systems for autonomous driving, as well as various like trust and safety efforts as well, including combating like spam and fraud and abuse across the platform. And so I think what was really fun and exciting is being able to work on uh, a pretty like widely applicable set of tools and technologies that are not like a single application focus. Like we didn't make like a single button on this
Hmm.
website better. It was kind of like we had impact across the horizontal breadth of different like product organizations as well.
Okay, very cool. And was were you working on a single product at the time? So, for example, first on YouTube's recommendation system, and then on a second one, and then on a third one, or was it all in parallel? Like you were supervising all the applications of GraphML at Google?
Yeah, it's a good question. I think when when especially at Google, which is I would say like particularly within research, like there are two ways to kind of tackle product thinking. And like one is like problem oriented, which means like, okay, there exists this problem or this expensive process that we want to optimize and fix. And now let's come up with a solution to tackle it. On the other hand, there's like the more of the novel, innovative, like research led approach, which is like, oh, we published this novel algorithm in this paper, which yielded some pretty exciting results. And it's exciting, but we don't really know what it's useful for yet.
Hmm.
And so it's kind of like you can tackle product thinking in both directions, like problem oriented or solution oriented approaches. Um, I got to do a little bit of both. Full transparency, like when I joined the team, there were like projects that, or let's put it this way, like stakeholder customers, okay,
Hmm.
within the organization that were certainly like bogged down by these expensive processes and um, a number of issues. And so we were trying to come up and we were trying to identify if GraphML or graph algorithms were able to help solve those problems better. But on the other hand, like in parallel, there certainly were novel like research experiments going on that took a great deal of kind of like to some degree networking and trying to understand the breadth and scope of different teams and existing issues and priorities to try to map those uh, research experiments and see if we could validate them with like a real customer problem, with most of the customers being internal teams at Google.
Okay, so the transition, making sure that what the research team does, I mean, try to make sure that what the research team does actually gets applied and gets as useful as it can for Google in terms of products.
Yeah, and not all research ends up
Yeah.
being productized and used, but I think um, that takes a degree of like skill, experience, timing, and a bit of luck uh, to be able to work backwards and say like there is this technological advancement that we believe can be applied to a number of problems and actually going through the like very quick almost like 0 to 1 style validation and prototyping and mapping to user stories and user pains. And then there's, once you validate it with a team for a particular, project or a single data set, you have to figure out like, does it actually scale, to
Mm-hmm.
Google scale, to
Mm-hmm.
like billions and trillions of nodes or tokens. And so, um, yeah, I think it's also good to not just validate products or solutions, but also invalidate them very quickly so that
Mm-hmm.
you avoid like tremendous sink of like time, energy, resources, and capital.
So can you give a particular example where you use some research algorithm for a product, either applied to YouTube recommender system, because that's a very interesting algorithm, but if you've got another example in another project, that's also fine.
One of the projects that I applied machine learning algorithms to, which is um, really exciting and kind of more external facing, was actually a library called Neural Structured Learning within TensorFlow. So it's used for a variety of applications, but particularly what it's able to facilitate is um, a set of like robustness techniques to help safeguard applications from adversarial and organic perturbations. So one example of this is, imagine you have like an image classifier that you're using to detect certain classes of
Mm-hmm.
clothing or cars or whatever it is that your website and application is meant to do. Um, Depending on the photos that people upload, they're taken at different orientations, different cameras, different image qualities. Um, Maybe you're even getting like a scan of a photo, right? And so being able to measure and improve the robustness of your classifier is a very important aspect of your application. I think that is more of like the organic. If I bifurcate the two, like acquisition channels of like images that you might receive, different skews and orientations is one that's kind of like organic perturbations, and then you have like adversarial perturbations. I think like anywhere that you see good actors, bad
Mm-hmm.
actors exist like behind the scenes, and it's constantly like a cat mouse chase. And so there are sophisticated and not so sophisticated ways of nesting images, pixelating images, um, you know, providing different like blurs and gradients and you know, creating different adversarial techniques to actually trick your classifier. And so I think like this this set of neural structured learning tooling and APIs helps facilitate robustness, which is extremely useful for a wide variety of applications.
Yeah, I think I saw a paper a couple of years ago where you've got an animal or something and you change a couple of pixels. For the human eye, you see exactly the same picture, but you change a couple of pixels, the computer sees something different, and suddenly it's a fruit or something. I don't remember exactly, but something completely different than the original image. And I was quite impressed by this. That's only by changing a couple of pixels um, that a human cannot even see, you get a completely different answer.
Exactly. And a common example of that from the adversarial like work stream is, we have people who try to like bypass image classifiers with not suitable for work content. And you would be surprised at what types of like nested
Mm-hmm.
trickery uh, happens with images to try to like send out these advertisements that violate terms of in conditions of different applications.
And so the process to get back to the project was some researchers implemented state of the art, a new graph neural net, and you kind of had the vision of making a library with this algorithm in order to avoid adversarial attacks. Is that kind of how it worked?
So there was an advancement in the research for a particular type of graph algorithm,
Mm-hmm.
which helped support robustness within different types of models and model architectures. And one natural application uh, of this particular research project was applying it to kind of one of the biggest pain points that I saw within the ads org at Google, which was like our image classification for advertisements, which was
Mm-hmm.
like constantly being, we were constantly getting reports of uh, bad ads or spammy ads across maps and search and different parts of the Google portfolio. And so trying to improve those classifiers internally kind of led to this, uh, natural sequential kind of like, oh, this, if it's useful for us, it's probably useful for other people.
Okay, interesting. And so, yeah, you work for Google on very technical topics, but as a product lead there, you have quite a big impact by implementing, I mean, bridging what researchers do and having some impact on the business internally and externally. And a couple of years later, you join OpenAI. You're now working at OpenAI on the LLM evaluation team. First things is, well, how did you join OpenAI? How did you get to work there? How did you make this transition? I think after Google you had a bunch of experiences, but how did you end up joining OpenAI?
Yeah. Um, I was actually working as as VP of product for a machine learning observability company called Aporia in Tel Aviv. Um, and machine learning observability is maybe kind of like a fancy term for uh, Datadog, but for machine learning models. So being able to really identify and um, investigate model specific issues like performance degradations or model drift or data quality issues. And so I was very focused on building products for um, measuring, investigating, and actioning on model performance across not just like models as an entity, but like
Mm-hmm.
across systems and applications. And at the time, naturally, OpenAI was gaining traction and kind of ChatGPT blew the world up
Mm-hmm.
and for the right reasons. And it was extremely fascinating. You went from like assessing model quality for these fairly small, like simple model architecture, discrete classifiers, to a billion token, hundreds of billions of tokens now being nested into a single large language model. Um, Much more generally applicable, much broader use cases, much higher uh, capabilities and performance. And so um, I was fascinated, and um, I actually wasn't looking for a new opportunity. I was fairly content at my role and had a lot of impact. And they reached out to me. Um, Someone in my network, I guess, was like perusing my personal site or my LinkedIn and reached out in a LinkedIn message and said, "Hey, um, I passed along your resume and your experience is extremely relevant, and we're looking for someone to help lead our evaluation team within OpenAI." And it was kind of one of those opportunities that was very difficult to
Mm-hmm.
refuse. And so I think like a tremendous number of interviews later, like maybe like 8 or 9 interviews later, um, I found myself moving from Tel Aviv to San Francisco.
When did you join the company? It's been a couple of months now. Is that right?
I joined in December, early December.
I'm keen to understand a bit more your current role at OpenAI. We mentioned that you're working in the LLM evaluation team, but what's your role like, and what does this really mean to work on the LLM evaluation?
Yeah, so being part of the model evaluation team is it's really interesting because the objective of the team is to not just like measure and benchmark our model capabilities, but to really assess uh, what it means for the model to be good at something. And as you can imagine, like what we perceive to be good today is much better than what we perceive to be good even 6 months ago.
Mm-hmm.
And so it's kind of like this constantly moving target of figuring out what sort of intelligence does the model need to exemplify and be proficient at? What sort of domains does it need to know about and reason about? What sort of capabilities should it be able uh, to perform with what degree of precision? You know, so it's really a fascinating science of figuring out how smart is smart, how capable is truly capable, and how do you consistently improve those capabilities across different domains, areas of expertise, um, and the breadth of things that our users care about.
And yeah, is there also this? There is also, I feel, I've done a couple of projects, GenAI projects, and there is also this challenge of I have two models. How do I really know that one is better than the other? Is that also a challenge on your side, or maybe because you've got, I mean, lots of data, lots of processes, that's an easy thing for you, or is it still difficult to be sure that one model is actually better than the other because it can answer a set of questions or a domain of questions correctly, but be slightly worse in another area, and so it's not like a traditional ML algorithm where you've got a mean absolute error and the algorithm that gets the lowest error is the best. LLM, it's a bit more nuanced, right?
Yeah, it's a great question and like a daily struggle. This candidate model versus incumbent model, which one is better? And I think the biggest challenge there is you oftentimes have a pretty diverse set of eval data sets, which you run various benchmarks on. Um, and you might excel or improve in one eval and regress in another, right? And so how do you really like balance out the decision making of ultimately, is this model better or worse? And I think there are like several techniques that we've developed in OpenAI which are novel and really inspiring, and I think that's the more creative aspect of my role, which I'm very fortunate to be kind of pushing. And I think, one other thing that's very interesting is actually being able to come up with uh, different constraints and visualizations to try to make sense of this data. I think the difference in, the way you described my work at Google was kind of bridging the gap between research and you know product, or
Mm-hmm.
things that get exposed and used. And the way I would describe my work here is like bridging the gap between metrics and like actionable decisions, because I think like that bridge between metrics and just these like numbers that give you like a score on how well you did here, how well you did on this eval, like don't really tell a story.
Mm-hmm.
And so being able to make sense of that in like a novel fashion is something that I'm super passionate about because like to me a metric is not an insight. Like a story is an insight. How did we get here and what can we do to improve this? And so bridging that gap between the metrics and the action that a researcher should take to fix something or improve something is kind of the science that we're working on.
Yeah, so it's not enough to just look at the numbers and see, okay, this model is an improvement on this particular metric. We're going to release it to everyone. It's a bit more nuanced, especially for LLMs.
Absolutely.
And well, keen to understand also, what's your advice like for people who build GenAI apps? What can they do if they want to make some improvements to their models? What can they do in their day-to-day to make sure that their LLM is actually an improvement? If they want to do some quick checks or some tips that they can do to make sure that the V2 that they build is actually better than the V1.
Yeah, great question. I think, in many cases, what's in everybody's best interest is to curate a data set or a holdout set, test set, whatever you want to call it, to evaluate your model regularly and make sure that test set is being updated continuously. And when it comes to model evaluation, right, and whether version one is better or worse than version two, right, the question I often ask folks is, what is the cost or the consequence of a missed prediction, of a false positive or of a false negative? Because in the case of autonomous driving, right, the cost is very high. If you perceive a human as a cone,
Mm-hmm.
it could lead to a fatality, and God forbid that happens. Whereas if your credit card company perceives your, um, you know, expensive shopping spree as fraud, and they block your credit card, like the cost of that is probably not you switching credit card companies. It's like an inconvenience or a text message that says, "Hey, is this really you?" And so, while let's just say, model version one is actually better in terms of its false positive rate than model version two, but model version two latency has improved significantly, right? Again, I asked the question, what's the cost of this misprediction if your model were to hallucinate in this way or give a wrong answer in this way? So um, get your golden test set, continue to curate it. Users' behaviors drift, data drifts, and so make sure that you're continuously measuring progress and updating that data set so it's reflective, diverse, and representative of what you expect to see in production.
Okay, that's interesting because that's actually quite close to regular ML. Like you need a very good test set that's representative, and you also need a bunch of metrics. Usually one metric is not enough. You talked about latency, about false positive. There are other metrics, and then it's what you're doing now, like a story between the metrics and the actual business goal. So it's not enough to look at just the metrics. It's also telling a story or sharing a story, summarizing all the information that you've got and making sense of this data to then say, okay, is my model really better or not?
Absolutely. I think like fundamental principles apply everywhere. I think it's um, building on top of these fundamental principles to really differentiate yourself and your science for decision making.
So a few general questions I have on OpenAI. I mean, the first one is, where do you see the future of the field? Like, more for you, we've got, so OpenAI released Sora, which is more of a visual model. We've got ChatGPT, which is more of a text model. So multimodality is probably the future there. Agents are also becoming more popular, but where do you see the future of GenAI and LLMs?
Yeah. Um, it's hard to predict, but I'm super excited about it. I think, when people throw around the word AGI, uh, what does that really mean?
Mm-hmm.
I I find it analogous to like product market fit, which is something that not a lot of people can define or describe, but every product person or founder or CEO who has like built something that has reached product market fit can like attest to the fact that when you get there, you know you're there. Maybe it's because your servers aren't scaling fast enough that you can't acquire enough GPUs, that like you truly can't handle all the user requests that are, flooding your support channel or customer service channel. And so, I'm not sure how to define AGI, whether it's like X number of modalities or being better on these sets of advanced placement exams in these domains, right? But it's something that I hope and am optimistic about because I truly believe that AGI will help alleviate a ton of societal and global issues that I feel are very difficult to reason about and very difficult to come up with constructive, better solutions across a variety of important industries, from medical to finance to tax to policy research. And so I I am very excited about the future of OpenAI and the fact that, its mission is to build safe AGI, which I think is like a critical keyword there. Um, and I think, we're not too far from it, which is exciting and, some would say terrifying, but again, I'm optimistic about the good use of this type of technology, which I think could truly benefit humanity in ways that nothing uh, like it has ever had such a grandiose impact.
So you don't know how AGI will look like, but you think that once we'll get it, we'll know it because demand will just burst and well, if you invent the algorithm, OpenAI will just get so much demand that you will suddenly realize that it's there.
Yeah, or if you think about it, like when you first interacted with ChatGPT per se,
Mm-hmm.
right? I'd like to think you were blown away. Or
Yeah,
I'll speak for myself. I'll say I was blown away,
yeah.
right? And so, while I could do a ton of stuff, and it was like this impressive, hard to believe that it was a machine at first glance, right? Like, if you were let's take you back in time, and you were a 4-year old or a 5-year old or just like an infant or a child, there's probably not a lot that you could ask it that it couldn't answer, couldn't help with. Um, and so, maybe some would say the current state of the art large language model is AGI for, a child's level of thinking and reasoning, right? And so as we as humans have advanced, right? Like again, it's kind of this moving target of what is AGI? I think we'll know when we get there, not just because of the flood of demand, but because of the positive change that was so stagnant for, decades, if not centuries, in different areas, right? Like maybe it's cancer research. Maybe we don't have to deal with, losing loved ones because we've synthesized a drug that, you know, previously wasn't possible. Maybe it's, we don't have to deal with like, you know, global deprivation or hunger when it comes to, third world countries because we're able to innovate new ways to new methods for agriculture or new methods for, you know, synthetic meat or whatever it is. I think like we will have made very significant leaps in a short amount of time that weren't previously possible.
Yeah. And when will this happen?
I I hope within our lifetime. No, I think much sooner than I think much sooner than that. But yeah, I think you know within 10 to 20 years is a sure bet. Within 5 to 10 years is like a risky bet. But I'm optimistic, and I think like one thing that I can brag about at OpenAI that is different from other companies, startups, and the Googles of the world is the passion and the talent of the people that I work with on a daily basis is impressive. And the velocity at which the company uh, prides itself on, which is like moving quickly, ensuring that we follow, the safe principles that align with our mission, but making sure that we're continuously progressing in this like obvious upward fashion is like something that I've never seen at any other place.
you've you've got probably the dream job for anyone in AI or machine learning, or for many people at least. And you mentioned, I mean, obviously people are very inspiring, smart, working hard. What do you think it takes to get a job at OpenAI? What do you need in order to get a job?
I think working in OpenAI is a privilege, and while it's a you're describing it as a dream place, and it certainly is for many, and myself included, it's not the only place, and there are a ton of companies who are doing incredible things in machine learning and in artificial intelligence and in many other industries. And I I think like broadly speaking, one of the biggest lessons from my um, experience in the professional world, and especially in like the corporate, tech company space, is um, something that people don't often speak about is the you have these like arbitrary performance cycles. I think they're every 6 months, or sometimes twice a year or once a year, depending on the company, right? Where you get all this like feedback from your peers, and people get nominated for promotions and not promotions or whatever. But like the thing that has helped me level up as a person and as a colleague and as a professional, and in my relationships even, like, is proactively seeking criticism. Like, go out and do good work, and even if you hear that you're doing well, which is great, I think it's much more important to understand what you could do better. um, Whether that's in your communication, or whether that's in your, product thinking, or your ability to dive uh, deeper technically, um, or your ability to empathize with your engineering team. And so it's not a specific answer to, how
Hmm.
do I work at OpenAI, but like broadly speaking, how do you level up in your career? It's proactively seek feedback and encourage people to feel comfortable giving you honest feedback. Because I think that's much harder than just asking the question of like, hey, do you like working with me? Hey, is there anything I could do better? It's providing a comfortable setting for someone to feel confident in being honest with you and saying, I think you dropped the ball here. Here's how it could have been done better. And I think that is a key piece of advice that I learned, um, learned by waiting till I had a performance review to hear something, which I kind of questioned and was like, oh, if that's the way you felt, why didn't you tell me sooner? We
Mm-hmm.
worked for 6 months on this, and I would have loved to know earlier, so I could have made a change. And so that's my answer, and like the one takeaway that I would want anyone who's interested in pursuing and leveling up in their career to really do.
Okay, no, thanks. Definitely a great advice. Maybe one last question on LLMs and OpenAI. You talked earlier that you want to make safe AGI. We also talked that you work in the LLM evaluation team. So, do you have safety metrics on top of performance metrics to evaluate LLMs? And how important are those safety metrics? Because obviously, safety is like
Yes,
a key concern. Like as you mentioned, there is technology that's very powerful. It will do lots of goods, but it can also do other stuff. So I know it's a big concern for OpenAI, and yeah, I was keen to understand if this is taken into account in your evaluation.
absolutely. It is one of perhaps the most scrutinized set of metrics and insights that we monitor is our safety evaluations, which span a number of categories, domains, capabilities, and we continue to improve those. And I think, especially when it comes to safety of models, it's also to think about like safety of broader systems and, how do you prevent someone from using a model in a safe way to uh, implement or develop a system which maybe acts in a malicious way, right? And so safety can be anything from, refusing to uh, answer questions about, how to do dangerous things to uh, ensuring that our technology is not used to manipulate, deceive people. Um, and, we mentioned, you have a breadth of evals that you run continuously. And one of the things that I was talking about was like, okay, the difference in improvements and regressions across model versions. Um, you should, and it's fairly normal practice to have a set of evaluations that are what you might consider constraints. Like even if you improve on 80% of your evals in this new model version, but you regress in your set of safety evals or constraint evals, those are things that they're deal breakers. And so we take that very seriously. And I think that's the right approach.
Okay, great. Well, and so you've got safety evals. What are the other categories of evals that you would look into? If you can give like maybe a few broad categories. I know we cannot get into the details, but keen to understand a bit more what you're looking at.
Yeah, I can't discuss the
Okay.
categories or the domains that we specifically target, but I think one thing I would encourage you to look at is there are some publicly available benchmarks like open source academic papers and evals that a lot of models are tested against. There is MMLU, which is a massive multitask language understanding paper um, that covers 57 domains, everything from like physics, chemistry, biology, law, medicine, etc. Um, there's there are papers like GPQA, which are like very advanced, complex reasoning exams. And so, we try to make sure that we really look at our model evaluation holistically, meaning not just like specific domains and capabilities, but also what are the types of prompts and queries that our users care about.
Okay, great. Well, I will link this article, this paper in the description. And yeah, I think we can close the OpenAI chapter. Yeah, thanks a lot. Super interesting to get to know a bit more about this. The last question, I think you shared a bit on this already, but I ask it to all my guests. If you had one advice for people to progress in their career, what would it be? Just one advice.
Yeah, I guess I spoiled this question already, but I think it's worth mentioning twice, which is, proactively seek feedback. Don't wait for, a formal arbitrary performance review. Um, don't just look to your, manager for feedback, and constantly think about ways that you can improve as a person, as a colleague, and as a mentor to others. I think that's super important. I've only found that um, paying things forward, like helping others and mentoring people, and spending time to help someone, whether they're in your first degree on your team, first degree network, or you know, maybe like second or even third degree network that you somehow, bumped into, like that has only ever benefited me.
And so is there also a part of you should also take responsibility and give feedback to other people because it will make them progress a lot?
I think that is a really valid question, and it's a really important quality to have. I'm not sure, I guess in my experience, like it takes a certain degree of uh, maturity and open-mindedness and willingness to improve, to seek out that feedback. And sometimes, you may find yourself in a position with complete good faith and goodwill in wanting to give someone feedback or constructive criticism in a positive way.
Mm-hmm.
um, they might not always be ready to receive that, or may not be looking for it. And um, I think it's actually a really good question. Uh, I would always opt for trying to have that conversation, and if you see it doesn't go well, worry about im- improving yourself in the best possible way, and of course, encourage others to do so to whatever degree they're willing to, and they want to get better.
But the main advice is seek feedback and be ready, obviously, to take negative feedback and improve on it. Because if you just seek feedback for the positive things, that's obviously not gonna work well.
Yes, if I didn't emphasize this, I should have. So,
No, that was
the
quite
goal,
clear.
yeah, the goal is to actually like pursue the things you need to improve.
Well, Reah, thanks a lot. It was great to chat with you and learn a lot from your experience. Thanks a lot. Have a great day in the US. And yeah, let me know if you come to Paris at some point. It will be great to have a chat. Yeah, have a great day and see you soon.
Thank you so much for having me, and this was a pleasure. And I'll reach out next time I'm in Paris, and please reach out if you find yourself in San Francisco.
Thank you. Bye.